Welcome to This Is My Architecture. I'm Matt, and I'm joined by Mary from UC Santa Cruz Genomics Institute. And today we're going to talk about how she's using AWS to enable cancer research. So Mary, tell me about what you're doing with AWS.
Great, so just to give you a little bit of context, at UC Santa Cruz we're processing sequencing data. There are a number of different processing steps that needs to happen for each sample that comes to us. We are processing actually quite a few samples altogether, on the order of tens of thousands of samples.
Wow.
And each of these steps are different Dockerized containers that we then run all together. Each of these samples needs to be run in the same way so that in the end we get data that is all comparable to each other.
Great, so how much data are we talking about? I think you said tens of thousands or a lot of samples. So what does this add up to?
Right, so for each sequencing file, for each one of those samples is around gigabytes. So pretty quickly we're getting up into the petabytes of data.
Wow.
Yeah.
That's a lot of data. So you're storing this in S3? I see the bucket down
Yes, yes. So we're storing all the data. We transfer it into S3 here.
Great.
And then we use SimpleDB to keep track of the metadata around those files.
Great. So why are you using the combination of SimpleDB and S3? I mean, I know S3 is a good, durable place to put a ton of data.
Right.
Why the need for SimpleDB as well?
So SimpleDB gives us basically strong consistency guarantees. Make sure that the files there are actually there. And then we used S3 actually just to make sure that we were able to transfer these petabytes of data around very efficiently using Amazon's internal, just great bandwidth.
Okay, so you get the petabytes of data in S3, you have the metadata in SimpleDB. How are you actually processing this data? Tell us about the architecture up there.
Right, so we use a leader worker system here. We have the leader node, which has a leader process here, and then a batch system. And we used Mesos for this.
Great, so this is a parallel processing system you're doing?
Exactly. Although we did make it so that for the batch system, you can put in any sort of batch system you might want, such as Grid Engine or something like that.
Oh, perfect, okay.
And then we also have a scaler here, which is spinning up and spinning down each of the different instances on the spot market.
So these frameworks like Mesos and the processes like the scaler, they're running on EC2 instances?
Exactly. So this is all running on one EC2 instance here.
Got it. So sort of the master, the brain.
Exactly.
And then it's controlling some kind of a cluster for parallel processing?
Right. So this is our EC2 spot cluster, which is all exclusively on the spot market, which we did to just sort of help keep costs low.
Yeah, because I imagine when you're dealing with like petabytes of data, the costs can go up from a processing perspective. Is that why you went with Spot? Or?
The cost can really just balloon out when you're dealing with this much data, this many samples.
Yeah.
We wanted to keep the price low, and especially just a lot of the people who are running cancer research data are on tight budgets, so we wanted to make sure it was affordable for them.
Okay, great.
Each of these different spot instances are then spun up and then are assigned work by Apache Mesos.
And what kind of work, like what languages or frameworks are you doing to actually do the work?
The work is in Python, and then those are running different Docker containers. And the Docker containers can be written in a number of different languages. It's just sort of whatever the person who developed that algorithm decided to write it in.
Okay, so that's really interesting. So you're actually, there's Docker containers running inside the EC2 spot cluster to do the processing in parallel. So it's kind of like parallel. You can have multiple containers per instance and many containers running in parallel.
Right, right. Yeah, so each of these spot instances are running several different worker processes all in Docker containers,
Now what happens when, I mean, EC2 spot is wonderful, but when you set a price target and the price goes up, the spot instance goes away. So how do you tolerate node failure in your cluster?
Right, so that was one of the things we really spent a lot of time on, trying to make sure that we were able to accommodate that. And so what we ended up doing is that a lot of these big data processes, looking at this genomic data, there's a lot of intermediate files. It takes some time to run them, and they generate an intermediate file, which is then just thrown away.
Yeah.
So instead what we do is we really aggressively save those in S3. So at any point, if a process fails, we're able to go into the middle of a big genomic data.
You don't have to start again.
Exactly.
Okay, so cool. So when you're doing the processing, you're storing all these intermediate files in S3, and then if one of the nodes drops, you can spin it up really quickly again. So you essentially not only tolerate node failure, but keep the job time low by doing it that way.
Exactly, exactly.
Very cool.
Because the bandwidth is still pretty fast, but then still transferring files takes a little bit of time. So we really try and make sure that each worker process that's on each cluster is really using the same files as much as possible.
So you mentioned before like cost and time and on the order of months and
right.
So how much was it before, and then when you moved to this model, like how much faster or cheaper is it now that you're using Spot and other technologies in AWS?
Right, so we did a demonstration of this whole architecture, and we did it on one of the largest compendium of cancer research data, which is about 20,000 samples. And It was originally projected to take about 3 months on our clusters at UC Santa Cruz,
wow.
and we got it down to 4 days.
Whoa, so from 3 months of continuous processing to 4 days.
Yeah,
that's pretty wild.
Much, much better. And then also the pricing, we priced out just how much it would cost on Amazon just using regular EC2 instances, and it was going to cost on the order of $800,000, so almost $1 million actually. And we were able to get that cost down to $26,000. So.
Wow, so $800,000 to $26,000. That's pretty solid. So I mean, this is really cool. The fact that you're doing, Mesos leader nodes, sort of leader worker nodes with spot clusters, keeping price low, enabling the scientific community. Is this something you guys use internally, or is it something that others can use as well?
Right. So right now we're using it internally, but we're hoping to make this available to the community. But we do have the Toil workflow. This system is available on GitHub and is open source. So
anyone can contribute. And
we would love to have contributions.
Great. Well, this is amazing. It's really wonderful to see you enabling such an important research for cancer on AWS, and really appreciate you taking the time to explain it to us today. So thanks for being here, and this is my architecture.